In this video, I'll be going over how I set up my Microfluidic CAD for CNC machining. I'll start by making my stock workpiece. Top plane, rectangle, 75 millimeters by 25 millimeters. The acrylic I'll be using is actually 9 to 30 microns in thickness, but for the purposes of this video, I'll go ahead and extrude it 1 millimeter. As a side note, these models are not going to be DFM friendly. When making my model for CNC machining, I need to be considering my feature sizes and which tools I'll be using. To test the budget CNC, I'll be using a 100 micron end mill to make my 200 micron cross junction and 100 micron nozzle. I'll start with the oil inlet. Make a new sketch on the top face of my extruded body, and at the very center of my model, I'll add a center point slot. I'll make it 200 microns in width and 500 microns in length. I'll finish my sketch and then make a new sketch. This one will be for the water inlet. To make a reference line, over on the right-hand side, I'll click Construction Geometry and then add a line to the center. Now let's turn off the construction geometry and let's make a rectangle. I want to apply some constraints, so I'm going to make it collinear as it enters the oil channel. And then let's apply some symmetry constraints. And finally, let's apply the dimensions. I'll make it the same as the oil inlet, 200 microns in width and 500 microns in length. For this one, I'll go ahead and cap it using the tangent arc. Finish the sketch and make a new sketch for the nozzle. Again, let's use the line type construction to make a reference line. Turn off construction geometry and make another rectangle. For the constraints, make it collinear to the end of the channel, and then make a symmetry constraint. Now to apply some dimensions, I'll make it smaller. Let's make it 100 microns in width, 400 microns in length. Again, I'll also cap this one using a tangent arc. Before exiting the sketch, I'm going to just quickly check that everything remains symmetrical when I change the dimensions. This will be handy for when I'm setting up my CAM files. Now let's exit the sketch, and let's go ahead and cut my channels to be 100 microns in depth. Let's select each of the profiles, enter negative 0.1 for 100 micron cut depth, and then hit OK. Finally, for organization purposes, I can go ahead and rename my sketches so it's easy to return to the sketch if I want to modify my dimensions. I'm constructing this geometry in this unique way because I know I'm going to be suppressing specific features when I set up my CAM. I only need my cross junction and nozzle to be small, so instead of making the connecting channels 200 micron width, I'll make them wider to save on machining time and use a larger end mill to preserve the tool life of my 100 micron end mill. Now, let's go ahead and make my serpentine channel for my water inlet. I'll make a construction geometry line on the diameter of my arc. Now let's turn off the construction geometry line and make a new line originating from the center point of that newly made line. And then I'll make this one 4 millimeters in length. To make the serpentine, I'll go ahead and make a couple of line segments that are all parallel to each other, and apply some constraints so that once I change the dimensions, everything will change symmetrically. Let's make the two half arcs equal. The line segments connect to each half arc equal, and then finally the two lines at the center equal. Now, when I apply the dimensions, the serpentine should change symmetrically. I'll go ahead and use the pattern to generate the remaining turns of the serpentine channel. And finally, let's make a line to the inlet hole location. At this point, if I want serpentine channels for my oil inlet, I can go ahead and pattern them vertically. But for the purposes of this demo, I'm just going to make the oil straight channels. Before I exit the sketch, I'll use the fillet feature to apply a radius of 0.5mm on the edges of the channels. Using line segments for extrude thin features is a lot more convenient than extrude cutting a rectangular channel geometry. Otherwise, I'd have to go back in and apply different radius fillets to the internal edges on the final 3D model. For the oil channels, I'll use a similar strategy with the construction geometry line. Let's make a line on the diameter of the arc. From the center of that construction geometry line, let's make a vertical line, and then a horizontal line, and then another line back down to the center. I'm going to quickly check that it's horizontal before I apply a dimension of 30mm for the inlet hole of the oil channel. I'll make it 8mm and then drag the endpoint back onto the x-axis. For these corners, let's go ahead and apply a 1mm fillet. Then I'll make a horizontal construction geometry so I can mirror the oil delivery channel. After exiting my sketch, I can go ahead and extrude cut my channels. To get a preview, let's change my wall thickness to 500 microns and wall location to the center of the line. And then for the distance, I can go ahead and enter -0.1 to get a cut depth of 100 microns. I'm going to go ahead and finish selecting the remaining line segments to generate the channels. Now finally, let's make my outlet channel. And moving on to the holes. There's different ways to construct our holes. I prefer to use the hole feature. It allows me to change the dimensions directly from the feature itself, but to do so, I'm going to make a new sketch in order to position the holes at the center of the channels. Now, for aesthetic purposes, I can go ahead and make a flat on one of the edges, and I'll make a fillet on the corner so that there's no sharp edges. For CNC machining, this step is optional, but it's better to model it because it's what the final geometry would look like. At the internal corners of the channels leading into my cross-section, I need to make some fillets. For the CNC process, I want to make this radius the same radius as the tool I'll be using. Because I'll be using a 300 micron diameter tool to machine these channels, I'll need to be making these 150 microns in radius. Last but not least, let's go ahead and save my file. Now I'm ready to set up my cam.